Hello class, welcome to this lesson on 5.6. We're going to be talking about inverse relations and functions. So we're going to talk about how we find the inverse of a function and verify that the two functions are inverses. So we're going to be representing the inverse of a relation using tables, graphs, and equations. And the vocab that we're going to talk about are the composite function, composition of functions, inverse functions, and inverse relations. So let's talk about relations first and how to find the inverse relation. So a relation, if you recall, is any set of ordered pairs x, y, where usually we say that x is the independent variable and y is the dependent variable. An inverse relation is formed when you actually switch the roles of the independent and dependent variables, or you invert them. So invert means like you're swapping the roles or you're switching. This is why it's called an inverse. Remember that a function is a specific type of relation where you have these in which the same x value does not have two or more y values. So basically, if you don't have the case where any x value does not have two or more of the same or different y values rather, then it would be called a function. So if you have something where you have the same x value having two or different y values, then it's not called a function. So it's not a function. So if you look at the problem below, our relation is given by this first set of coordinates, right, x and y. Now to get the inverse, you got to invert the coordinates. So you're going to be switching the coordinates, right? And so now that's our inverse relation. And then if you look at this, well, we have the same x value here giving us two different y values, right? So therefore that's that's basically an indication that this is not a function, because like we were saying earlier, if you have the same x value yielding two different y values, then that would be not a function. So identify the inverse relation and is it a function. So you have a relation given below. Remember, a relation is simply any set of ordered pairs. So that's what's given below. Now, is the inverse a function? So let's do the inverse first. We're going to swap the x and the y coordinates here. So the x is y, y is x. So basically, we're going to just swap these. So you're going to have 9, negative 1, 7, 0, 5, 1, 3, 2, 1, 3, and negative 1, 4. So that's going to be our inverse relation. And then you're going to want to look to see we have any x values where the x is the same and then we have two different y values. Well, it looks like all the x values here are unique, right? So we seem to be good here, and because they're all unique and they all have different y values, then we're good here. So notice that even if you had two of the same y value, so let's just say that this were a 2. Well, this is, and so you have a 5, when x is 5, y is 2, when x is 3, y is also 2. Well, that will still be considered a function because you have the same y value, but you don't have the same x value, right? Giving you two different y values. So the key here is that the x value has to be the same, and then based off of that, then the y value changes. Okay, so that's what you want to look out for. But in this case, this is a function based off of what we were saying earlier. So this inverse relation is a function. All right, so now we're going to talk about how do we find an equation for the inverse of for the inverse function. So if we got an equation of a function, how do we get the inverse function from that? Okay, so we're going to look at this easy example, f of x equals x squared. And so remember that the inverse function means that you're going to invert x and y, right? So you're going to swap x with y. So now remember that this is equal to y. So we have y equals x squared, and then now you're going to go ahead and do the swap, right? So we're going to switch those now. And so now we get x equals y squared, just like that. All right, so then we go ahead and solve for y here. So if we solve for y, we got to get rid of the square root, right? So in order to get rid of the square root, or the square, I mean, we got to do the square root, just like that. But remember that if we take the square root of both sides, we have to include the plus or minus sign on one of the sides, okay? So there you go. We included it here. So now these square root cancels, leaving me with y equals plus or minus square root of x. All right, so that is our new inverse. Okay, so this is the equation for the inverse function. Now, normally we're able to replace y with f inverse, right? There's a symbol for, inverse. The symbol for inverse function is f inverse, like this. That's the symbol for the inverse function. However, I'm going to leave it as y because this actually is not a function, and we'll explain why in just a second. Okay, so I was telling you earlier that we did the equation, and then we did the inverse, and we got this, right? So we're going to graph both of these together on the same coordinate plane in order to determine, if there's a relationship between those two. So if we want to graph x squared, well, we know that, it's a parabola, so it starts at 0, 0. Then we got 1 squared is 1, and then we have 2 squared is 4, so we got 2 comma 4, and then negative 2 comma 4. So we have something that looks like this. Okay, so that's our parabola. That's y equals x squared. So now let's look at the inverse here. We're going to call it, so now notice we have two different functions here. We have the positive square root x here, and we have the negative square root x. So I'm going to go ahead and split this up. We have the positive version, and we have the negative version. So we have two different functions here, basically. So we have the positive square root of x. Remember the square root of x function? We'd actually graphed that last lesson. It starts at 0, 0, and then we have 1, 1, because the square root of 1 is 1. And then we know that the square root of 4 is 2. So I'm going to go to 4 comma 2. So right here, this is 4. And then that's y equals 2. And then I know that when x is 9, well, I know the square root of 9 is 3. So I'm going to go to 9 on the x. 1, 2, 3, 4, 5, 6, 7, 8, 9. So over here. And then 3 and the y. All right, so there's my positive square root of x right here. Now let's do our negative version. The negative version, you're just going to flip it about the x-axis. Okay, so this is the x-axis over here. This is the y-axis. So we're just going to reflect it. So that means it's going to be like this. Negative 1, negative 2, and then negative 3, like this. So it's going to be reflected. So then we have something that looks like that. So that's our negative square root of x graph. All right. So now we can kind of see, well, this is definitely not a function because it fails the vertical line test, right? So right here, not a function. Remember that the vertical line test states that if you have a vertical line, right? Maybe like a ruler or something like that. If it touches that vertical line at more than one spot, you see how it touches there and there? If it touches it at more than one spot as you slice, as you go through the curve, well then that is considered not a function. Okay, so that's the vertical line test. So I want to make sure that you guys remember what that is. Okay, so it's not a function because it fails the vertical line test. All right, so we got a couple of things here. So we know that the inverse is not a function in this example, and we know that the original function is an inverse, right? So the parabola is clearly an inverse, but the inverse is not. The parabola is clearly a function, rather, I apologize, but the inverse is not a function. So now, what's the difference between, what's the relationship between the blue and red graph and the black graph? Well, it turns out that this is actually a mirror reflection of the black graph. It's a mirror reflection about the equation y equals x. So we're going to actually graph y equals x. So that's going to be a straight line starting at the origin, and then 1, 1, 2, 2, 3, 3, like this. And then we're going to connect that. I'm going to try to make this a little bit better. Oops. There you go. All right, so now if you look at this, this is actually a mirror reflection, right? If you look at this first part of the, right here, if you think of the green as the mirror, well, this is a reflection on both sides, right? There, and then same for this side, and even same for this and that. They're a mirror reflection. So therefore, there is a special relationship between the original function and the inverse, in that the inverse function can be found, or the inverse graph rather, can be actually found from the original function by mirroring it about the equation y equals x. So therefore, the graph of the inverse of f is the reflection of the graph of over, so we should probably say the reflection of the graph over the line y equals x. So over the line y equals x. All right, so there's a special relationship there. So I could basically give you any graph, and if I ask you to graph the inverse graph, you can just use this method and just kind of reflect it based off of being the same distance away on both sides, a reflection. All right, so we'll talk about doing more, finding an actual equation of the inverse for more like different types of functions. So we did it for the square function, the parabola, the quadratic function. Now let's look at it for square root and cube root functions, which are part of this unit. All right, so if we want to find the equation, remember that you can set this equal to y. And then now you swap x and y. So now you got x is y is x. And then now we're going to solve for the new x. So now we're going to, the only way to get rid of the square root is to square both sides. So we get x squared equals y minus 2. Then we're going to add 2 to both sides. And we get, I'm just going to put the y now first. Y equals x squared plus 2. So there's our equation. Now I know that this is a parabola that is shifted up 2 units. So I know that, the parabola's here, it's, something like this. So I know that's what this is. So I know that it's clearly a function, so I can leave it as y equals x plus 2, or I can use the function symbol, because now I know that this is a function, because it passes the vertical line test. If you were to draw vertical lines, it only crosses it at one spot. So I'm just going to go ahead and call this f inverse of x. equals x squared plus 2. So either one of these is correct, but we're going to use the inverse function in this example notation. All right, so let's look at part B. Again, this is the same thing as y, and then swap x and y. All right, so then we're going to use the idea for the next unit. Remember to isolate the radical first. So I'm going to go ahead and subtract the 2 on both sides. As such, then I'm going to get rid of these negative sign by basically flipping all the signs on both sides of the equal sign. So I'm going to flip this to a positive. This is going to be a negative now. This is going to be a positive. There you go. So that negative is now gone because it became a positive, and I can erase it now. And then now, the only way to get rid of the cube root is to do the cube operation because they're opposites. So now they'll cancel out with the radical. I got to do the same thing on this side. All right, so now we have this guy cubed equals y plus 1. So we have this cubed equals y plus 1. And then I'm going to go ahead and subtract 1 on both sides. And I'll get my inverse, the equation of my inverse. I went ahead and put y first instead. All right, so how does this graph look like? Well, remember that this is a cubic function. So it's going to look, the cubic function looks something like this, right? Y equals x cubed. And then the negative means that it's reflected about the y-axis. So it's going to be reflected, something like this. And then the plus 2 indicates that it's going to be shifted left or right. In this case, it's actually going to be shifted, to the right because of the negative sign. So it's going to be actually shifted to the right. So it's going to be reflected, shifted to the right, 1, 2. So maybe something like that. And then it's going to be shifted down 1. So then it's going to be shifted down. So it'll be something like that. So we have our graph that looks something like this for the new function. But in any case, just to kind of visualize it, that's what we have. But we know that it's a function because it passes the vertical line test. So we can go ahead and replace this with f inverse of x. Now, if you wanted to leave it as y equals, that's perfectly fine as well. Okay, so this is what I'm going to write, or that. All right, so now we're going to talk about composition, the operation, and what that entails. So a composite function is the result of applying the rule for one function to the rule of another function. So basically, you're plugging in one function into another function. So it's sort of like a nesting of functions, like a function within a function. So the new rule we call this operation, a composition operation, and it's denoted by a circle, right? So it's denoted as F circle G. So that's what this is here, F circle G. Now F circle G, or F composed with G, so you can call this F circle G, or F compose G, or you can say F of G. Okay, so either one of those is considered valid. So F circle G or F of G. So basically what this means is you're going to take the first function right here, the G, and you're going to plug it into F, right? So that's what this is here. This is F, and you're going to plug in the G inside of F. So what does that actually mean? Well, that means that you're going to take the entire rule for the G of X and then plug it into the old rule of F of X and get a new one. So we'll show you an example of how that looks like. So regardless, the operation is called the composition operation. And there's one special property of this operation. The property is that if you compose a function with its inverse, then you're always going to get the value x. And if you switched it, you're also going to get x. So if f and g are inverses and you compose them together, then you're going to get x, even if you swap them with g circle f or f circle g. So both of these have to be true in order to be considered inverses. Okay, so if one of these is not true, then it's not an inverse. Okay, they both have to be true for f and g to be considered inverses. So we're going to actually test this out on a few functions. So what is the inverse of f of x equals 2x plus 5? Verify this by using composition. So again, let's do the inverse first. So this is going to be y equals 2x plus 5. This is y here. And then swap x and y. So we get x equals 2y plus 5. And then we're going to solve for y now. Subtract the 5. And then divide by 2. All right, so that is my inverse function. F inverse x equals x minus 5 over 2. Okay, so that's my guy. So now, and I'm gonna, so this is f inverse. So now what I'm gonna do is I'm going to compose f with f inverse. So I'm gonna verify that this is the solution. Okay, so this is my solution for the inverse, but let's verify. So we got f of f inverse, which is, that's the same thing as f circle f inverse. Okay, that's what that is. Okay, these mean the same thing. Okay, these mean the same thing. So now what we're going to say is we're going to take f inverse and plug it into f. So let's replace f inverse with what we have here. So that's basically x minus 5 over 2. Just like that. So we plugged it inside. You see that the x minus 5 over 2 is inside the f. So what does it mean for it to be inside the f? Well, the f, remember that the f rule is the 2x plus 5. So basically what it's saying is that whatever the function is, if there's an x value in that function, it's going to be replaced with whatever is inside here, right? So I see an x here, so it's going to be replaced automatically with that x with this x minus 5 over 2. Okay, so I have 2, and now you see the x there is going to be replaced with what is on the inside, x minus 5 over 2. Okay, I'll color code that so that you can see that. So this x is in red, right? And that x got replaced with this part right here. And then plus 5. So if you have multiple x's, you're going to replace all the x's with x minus 5 over 2. All right, so now the 2's, notice that the 2's cancel out here, leaving you with x minus 5 plus 5, which these cancel, leaving you with x. So far, this is so far so good. Remember that we get x if they're inverses. So now let's swap them and say f inverse circle f. So let's do that now this time. And that's the same thing as f inverse of f of x. And what is f of x? That was the original function, 2x plus 5. So we're going to plug that in here, 2x plus 5. That's what this guy is. So what we're going to do is the inverse function is x minus 5 over 2. So this one right here. So you see this x here, we're going to replace that x with the 2x plus 5. So that x gets replaced with 2x plus 5. And then we got the minus 5 afterwards over 2 equals, so now the 5's cancel out here, and we have 2x over 2, and then the 2's cancel out, leaving us with x. So it checks out. So we know that these are definitely inverses. Okay, so a good way to check your work. Now, let's say that we didn't have to find the inverse, and let's say they gave us two functions, like these two functions here, and they want us to determine if they're inverses. Well, we can just go ahead and use the operation right away. So we're going to do f of g of x. So we're going to plug in g. G is square root of x minus 5. So we're plugging in G into F. So now we know that this is, let me get rid of this. This is F, right? And so we're using F here. And then this X that you see here will get replaced with this, square root of X minus 5. So I got X squared. So I'm going to do X, which is all of this now, gets replaced. And then we have squared plus 5. So that's how we plug that in. And then, so now we're going to go ahead and actually FOIL this out. So this right here is a FOIL, so we got to replace this with square root X minus 5, square root X plus 5. And then plus 5. All right, so we got a FOIL. So we got square root of X times square root of X is X. Square root of X times 5 is 5 square root of X. Negative 5 times square root of X is negative 5 square root of X. And then negative 5 times positive 5 is negative 25. And then of course we got the plus 5 that we got to bring down from earlier. So, I'm sorry, this should be a negative. I switched the sign. So this is going to be a negative 5 instead of a positive 5. Okay, so now these combine, we're going to combine these. So it's going to give me X minus 10 radical X, and then this is going to give me minus 20. So we got this weird function, and we shouldn't be getting that. We should be getting X, right? So none of these canceled out. So therefore this is not equal to X. There's nothing else we can do here. So right off the bat, we know that they're not inverses because we don't get X. Okay, so not inverses. So basically we'll say that F and G are not inverses. Okay, so once you figure out that you don't get X for the other side, then you're automatically done. However, I'm gonna show you how you would actually do the reverse operation where you put G first and then F on the inside, just so that you could practice to see how it looks like. Okay, so now we're using the G function. We're plugging F into G. So F is equal to X squared plus 5. So now we're using the G function, and we're plugging in X squared plus 5 in for X. So the X here in G gets replaced with that. So now we have the square root of that X squared plus 5. And then we got on the outside minus 5. And then you can clearly see here that there's no way that the 5 and the minus 5 can cancel out. There's nothing that you can do here. This is not equal to X. Please do not be tempted to get rid of the 5 and the negative 5, because this negative 5 is outside the radical, so it will not cancel. This will not cancel. Okay, you have 5 on the outside and 5 on the inside. There's no way to cancel those. All right, so not inverses. So let's use the composition to determine whether F and G are inverse functions for more practice. Okay, so let's do F of G of X. We know that G is that. We're using the F function, and we're plugging G in for that, right? So we're plugging this in for X in that function. So we have 1/4. Now we're plugging X, and then plus 7. All right, so now we're going to distribute. We have 1/4 times 4. Well, it's just going to cancel out, giving me X. And then 1/4 times minus 7. Remember, minus 7 is minus 7 over 1. And then 7 times 1 is 7. And then 4 times 1 is 4. So it's become minus 7 over 4. And then we got plus 7. All right, so we have X, and we got this weird thing in the very end. We got to combine those two fractions together. So let's give this a common denominator of 4. So we have minus 7 over 4 plus 28 over 4, which is X minus 21 over 4. So this is clearly not equal to X. So we can stop here and say that they're not inverses. So F and G are not inverses. They're not inverse functions of each other. All right, let's look at this one. So let's do f of g of x again. So plug in g of x is x cubed plus 1. And now we're going to be using the f function, but plug in for x, we're going to plug in x cubed plus 1. So we got the cube root of that, and then minus 1 on the inside of the radical. So now since the 1 and the minus 1 are inside the radical this time, they actually do cancel out. So now we have cube root of x cubed. And then the cube and the cube root are opposites, so they cancel, leaving you with x. So this checks out so far. So let's go ahead and cancel out and actually do the reverse operation. And we're going to plug in f now into g. So f is the cube root of x minus 1. So now this time we are using the g function, and for every x in that g function, use a different color, we're going to replace it with the cube root of x minus 1. So we have here equal to, so we got x, which now we're going to replace with x cubed plus 1. And then remember that that x was actually cubed, so we got to put a little cube there, and then plus 1. All right, so now we have something like this. And okay, so let me look at our original here. So we got g something is I'm sorry about that. I plugged in the wrong function. I'm supposed to plug in the red here, right? Okay, so yeah, so I knew something was a little bit off here. Let me go back. So for the x here, we're replacing it with the red here. Apologize. So that's this function. So we got the cube root of x minus 1. There you go. So I just replaced the wrong one. I need to replace it with the red. All right, so there you go. So x got replaced with the cube root. And then now we notice that the cube and the cube root cancel here, leaving us with the x minus 1. And then we got the plus 1 on the outside. And then these will cancel out, leaving us with x. So this checks out. So if you reverse it, you're still going to get x. Therefore, these are considered inverses. So f and g are inverses of each other. All right, guys, that's it for the video. I hope you learned something from this video, and I will see you in the next one.